End semester examination paper, subject Introduction to Data Science. We have first question: take a real world problem and explain how each crisp DM phase would apply to address this problem. Include at least one specific task under each phase. Problem: predicting customer churn for a telecom company. The goal is to identify others likely to cancel their service so the company can intervene. First is to business understanding. Determine business objectives. Task is define churn, that is no activity for 30 days, and set a goal that is reduce churn by 10% next quarter. Data science understanding. Collect and explore data, in which task is to gather data tables, customer demographics, call logs, billing history, and check for missing values or outliers. Data preparation. Clean and format data for modeling. Task is to handle missing values, that is input age with mean, create new features, that is average call duration, and normalize numerical variables. Modeling, apply algorithms to build predictive models. Task is to train a logistic regression and random fast forest model on the training data set to predict the probability of churn. Evaluation, assess model performance against business goals. Task is to calculate accuracy, precision, and recall. Check if the model effectively identifies high value churners. Deployment, implement the model in a live environment. Task is to integrate the model into the crisp system to flag at risk customers daily for the retention team. Now we have differentiate between structured, unstructured, quantitative, and categorical data with suitable real-world example. We can classify data in two main ways: how it is organized, structured versus unstructured, and how it represents, quantitative and versus categorical. Based on organization, storage, we have features definition of structured data: data that follows a strict predefined format, rows and columns, highly organized. Unstructured data, data with no predefined format, it is messy and disorganized. Storage of structured data, relational database, SQL, Excel, spreadsheet, CSV files. Unstructured data storage, data lakes, NoSQL database, folders of files. Searchability of structured data, very easy to search and analyze. Unstructured, difficult to search, requires AI /NLP to process. Volume of structured data, approx 20% of world's data, and unstructured data, approx 80% of world's data and growing. Real world example of structured data: a bank statement in which we have data amount, merchant name, it fits perfectly in a table. We have unstructured data in which we have example, a Zoom call recording, audio, video, and text chat mixed together. Now we have, based on nature, statistical type, we have quantitative data, numerical, categorical data, qualitative. Now definition of quantitative data is data that expresses a certain quantity, amount, or range. It is number you can do math on. Categorical data that describes qualities of characteristics. It puts data into group categories. Key question: how much or how many quantitative data? And categorical, what type of which group? We have math in quantitative data, which is arithmetic operation, average, sum, etc. makes sense. In categorical data, arithmetic operations do not make sense. You can't average blue and red. Subtypes of quantitative data: discrete integers, that is of kids; continuous decimal, that is height. Categorical data: nominal, no order, that is colors; ordinal, ordered, that is low, medium, high. Real world example of quantitative data: temperature 98.6 degree Fahrenheit, salary 50,000. And categorical data example: t-shirt size small, medium, large; car brand Toyota, Ford, and Honda. Now we have second question: demonstrate an algorithm that uses Bayes theorem that solve a small example with prior probabilities and likelihoods are given. Algorithm name bias classifier. Core concept: this algorithm predicts the class of a new data point based on probability. It assumes that the presence of particular feature in a class is unrelated to the presence of any other feature. Hence the name is name. Now foundation. The foundation bias theorem is equals to P A by B is equals to P B by A dot P A upon में PB. P A by B is posterior. The probability that hypothesis A is true given evidence B, what we want to find. Probability of B by A, we have likelihood like we have likelihood of the probability of seeing evidence B if hypothesis A is true. Now PA prior, the initial probability of hypothesis A being true before seeing evidence. PB marginal, the total probability of seeing evidence B. The algorithm steps: we have input, training dataset D, and a new instance X to classify output, the class with the highest probability. Now we'll calculate prior probabilities by the formula, calculate likelihoods by the putting it in the formula, calculate posterior probability putting in the formula, make decision, compare the scores, the class with the highest score is the prediction. Worked example: play tennis. Data: we have 10 days, 6 yes play, 4 no don't play. New scenario: weather is equals to sunny, should we? So priors should be P yes is equals to 6 by which is 0.6 and P no is equals to 4 by 10 which is 0.4. Step 2: likelihoods from the data. We have in these 6 yes days 3 were sunny, we have 0.5. In the 4 no days 3 were sunny, 0.75. Posterior score yes is equals to 0.30, score no is equals to 0.30. Fourth step: decision. It's a tie. In a real scenario with more features, one score would usually be higher. Now we have a question: compare the binomial, normal, and position distribution in the term of their assumption and application. So type of binomial is discrete, normal is continuous, Poisson is discrete. Assumption of binomial: fixed number of independent trials with two outcomes, success or failure. Normal assumption: data is symmetric around the mean. Bell curve: many natural phenomena follow this. Poisson assumption: events occur independently at a constant average rate over a fixed interval. Parameters of binomial and trials: p probability, normal, mu mean, null standard deviation, Poisson, lambda average rate. Application of binomial: tossing a coin 10 times, pass fail rates. Normal: heights of adults, test scores. Poisson: number of emails received per hour, traffic accidents per day. Now we have question: explain the data wrangling process with a suitable example. Data wrangling or data mangling is the process of transforming and mapping data from one raw data form into another format with the intent of making it more appropriate of and valuable for analytics. The three key steps are: discovering, understanding what is your data set, checking data types, spotting visible errors, structuring, organizing data. That is, the raw data might be in a weird JSON format and you need to flatten it into a CSV table with columns. Cleaning, removing noise, handling null values, fixing typos like California into California spelling, removing duplicate rows, enriching, augmenting the data. That is, you have a customer ID, so you join it with another table to get the customer name and address. Validating, logic checks, that is ensuring age is not negative or percentage is not greater than 100. Now publishing is saving the clean file for the analysis team to use. Suitable example: retail sale analysis is a scenario. A global company wants to analyze total sales, but the Data comes from two different regional offices, USA and India. Raw data uses file A. USA data format is MMDDYYYY. Currency is USDT. File B India date format is date, month and year. Currency is INR rupees. Both some rows have missing customer age. The wrangling process is to load both files into a Python Panda data frame. Clean fill missing customer age with the median age imputation. Transform convert file B's currency divide INR by 84 to get USD. Parse file B's dates to match the month, date, year standard. Enrich, add a new column region to label the data source. Validate, check if there is any negative sale numbers impossible and remove them. The output a single ununified table where all the currency is USDT and all data are dates are consistent, ready for analysis. What is the difference between error and artifacts in data cleaning? Explain any two imputation techniques. Data errors definition: incorrect values that do not reflect the truth. They are usually random mistakes. Data artifact are the systematic problems or distortions caused by the data gathering equipment or process. Cause of data errors: human entry errors, transmission noise, typos. Data artifacts: hardware glitches, software bugs, sensor limitations. Nature of data error: isolated and random. Nature of data artifacts: systematic and repeating pattern. Example of data error: a student's age entered as 200, typo. Data artifact: a vertical blank line appearing on every scanned document, scanner glitch. Imputation techniques: filling missing values. A technique A, mean median mode imputation concept: replace the missing value with the average of the column. When to use: mean for numeric data, that is temperature; median for numeric data with outliers, that is salary; mode for categorical data, that is color. Example: data is equals to some set of data 10 20 question mark 40 50. Mean is 30. New data is equals to 10 20 30 40 50. Now we have technique B, K nearest neighbor KNN imputation. Concept is to find the rows that are most similar to the row with the missing value and use their values to guess the missing one. Process: measure similarity distance between rows. Find the three nearest neighbors most similar students, average their scores to fill the blanks. Advantage: much more accurate than simple mean imputation because it considers the context of other attributes. Explain any four common features engineering techniques for continuous or categorical data. Feature engineering is the art of creating new feature or modifying existing ones to improve machine learning model performances. One hot encoding categorical data concept is to convert categorical variables into a binary 0 or 1 matrix. Problem: machines can't understand text like red or blue. Label encoding: red is equals to 1, blue is equals to 2 creates a fake mathematical order in brackets. Solution: create a new column for each category. Example: original color is equals to red blue red. Encoded is red 101 is blue 010. Min-max scaling normalization: continuous data concept rescales numeric values to a fixed range, usually 0 to 1. Formula: x dash is equals to x minus x min upon में x max minus x min. Now we have why essential for algorithm based on distance like KNN or K-means. Without it, large numbers like salary is equals to 50,000 dominate small numbers like age is equals to 25. Pinning and discretization: continuous data concept is to converting continuous variable into discrete buckets or categories. Why handles noise and outliers? Sometimes the exact age doesn't matter, just the age group. Example: converting age into life stage: 0 to 12 child, 13 to 19 teen, 20 plus adult. Log transformation: continuous data concept is to applying the natural logarithm function to the data. Why used for highly skewed data with a heavy tail? It compresses the range of large numbers, making the distribution look more normal bell curve, which many algorithms prefer. Example: incomes: most people earn 30k 80k but a few earn millions. The log transformation brings the million closer to the average, stabilizing the variance. For the dataset 12, 15, 12, 18, 20, 15, 30, compute mean, median, mode, and standard deviation. Explain when to use each measures. So dataset we have step 0 preprocessing. Always sort the data first. Sorted data. Now we have count n is equals to 7. Mean formula is x dash is equals to x bar is equals to summation of z upon my n. So will answer will be 17.43. Now when to use when data is symmetric bell curve and has no outliers. It uses all data points but is sensitive to extreme values like the 30 here. Now when to use when data is symmetric. We already talk about this. Now find the median, the middle value. Formula, the value position of n plus 1 upon my 2. So we have calculation, result is 15. When do you use when data is skewed or has outliers? It represents the typical value better because it ignores the extreme 30 mode. The most frequent value definition, the value as the upper most often is 12 appears 2 times, 15 appears 2 times, other appear 1 times. Result 12 and 15 by model. When to use for categorical data, that is most popular color to find the most common occurrence. Now fourth is the standard deviation, the spread. Formula sample is as is root of summation of x minus xi ka whole square n minus 1. Step by step table we have, which is the sum 235.68. Now variance is equals to 39.28. Standard deviation 6.27. When to use to measure volatility or consistency. High SD means the data is spread out. Low SD means it is clustered near the average. Now we have distinguish between parametric versus non-parametric models, supervised versus unsupervised learning. Parametric models that make strong assumption about the shape of the data function, that is it's a line. They have a fixed number of parameters regardless of how much data you have. Non-parametric models that make no assumption about the shape, they are flexible. The number of parameters often grows as the dataset grows. Complexity of parametric models, simple, fast to train, less data needed. Non-parametric model, complex, slower to train, requires a lot of data. Risk of parametric models, high bias. If the assumption is wrong, that is fitting a straight line into curved data, the model fails. Non-parametric models risk is high variance, can easily overfit memorize noise in the data. Now we have a parametric models. Example, linear regression, just find slope m and intercept c, and logistic regression. Non-parametric models, k nearest neighbors, knn, memorize the whole dataset and decision tree. Now supervised and unsupervised learning. Supervised learning, label data, input x comes with the correct output y. Unsupervised learning, labeled data, unlabeled data, input x only, no correct answers are provided. Goal is of supervised data is prediction to learn a function mapping inputs to outputs. Unsupervised learning, discovery to find hidden pattern structures or groups. Feedback of supervised learning is direct feedback. The model knows if it got the answer right or wrong. And no feedback in the unsupervised learning. The model must evaluate itself based on the data structure. Example of supervised learning: spam filter, classify email as spam or not spam. House pricing, predict dollar value based on size. Unsupervised learning example: customer segmentation, group customers by purchasing behavior. Market basket analysis, find items bought together. Now we have questions with reference to text mining. Describe accuracy, precision, recall F1, and illustrate their computation using a confusion matrix. The setup: imagine a model predicting if a patient has cancer positive or is healthy negative. So we will be actual cancer pros, actual healthy negative. We'll putting it in the value. TP is equals to sick people correctly identified as sick. TN, healthy people correctly identifies as healthy. FP, type 1 error, healthy people wrongly told they are sick. False alarm. FN, type 2 error, sick people wrongly told they are healthy. Missed detection. Now we have The matrix accuracy definition, the percentage of total prediction that were correct, formula TP plus TN upon my total computation, or 85%. Note can be misleading if classes are imbalanced, that is, if mostly everyone is healthy. B. Precision definition of all the people we said have cancer, how many actually do. Quality of the positive prediction, formula TP upon my TP plus FP computation, or 33%. Goal is minimize false positives. Recall sensitivity definition of all the people who actually have cancer, how many did we find. Quantity of true positives found, formula is TP upon my TP plus FN. Computation of 50%. Goal is to minimize false negatives, crucial for medical safety. And we have F1 score definition, the harmonic mean of precision and recall. It balances the two formula, 2 into precision into recall upon my precision plus recall. Computation, or 39%. Note, useful when you need a balance between precision and recall. Now, how our missing values are handled? Suggest three approaches. Standard approaches to handle missing data is deletion, list-wise or pair-wise. Concept is simply remove any row tuple that contains a missing value. When to use? When the data set is very large and the missing values are few, that is less than 5% of the greater than 5% of the data. Pros, easy to implement, preserve the distribution of the data, observed data. Cons, high risk of data loss. If you delete every row with a single missing cell, you might lose 50% of your data set. It also introduces bias if the data is not missing completely at random. MCAR, statistical imputation, mean median mode. Concept is to replace the missing value with a calculated statistic from the existing data. Mean is to use for a normal numeric data, that is height. Median used for skewed numeric data, that is with outliers, that is salary. Mode is used for categorical data, that is city. Pros, preserve the sample size, easy to calculate. Cons, distorts the variance by filling many holes with the exact same average number. You artificially reduce the spread of the data, making the model overconfident. Model based imputation prediction concept is to treat the missing columns as the target and train a machine learning model to predict it based on the other valid columns. Example, if age is missing, use education level and years experience to predict age using linear regression or k nearest neighbors KNN. Pros, most accurate, it uses the relationship correlation in the data to make an educated guess. Cons, computationally expensive and complex to implement. Explain logistic regression and use the logistic function to calculate the probability of a class for a given input. Example, definition, logistic regression is a statistical method used for binary classification problems where the outcome has only two possible classes, that is yes or no, 0, 1, spam or not spam. Unlike linear regression, which predicts a continuous number like price, logistic regression predicts the probability that an instant belongs to a specific class. Now we have the logistic sigmoid function to map predicted values to probabilities between 0 and 1. It uses the sigmoid function py is equals to 1 is equals to we have variance z is equals to 1 upon 1 plus e की power minus z. The linear combination of inputs is equals to z b0 plus b1 x1 plus n numbers, and Euler's number is equal to 2.718. Logistic function calculation example problem predict if a student will pass 1 or fail 0 based on our studies. Given data, intercept b0 is equals to -4, coefficient b1 is equals to 1.5. Input a student studies for hours. Step 1, calculate the linear equation z is equals to 2. Function to apply the logistic function, which we have p pass is equals to 0.88. Make a decision threshold. Standard threshold is equals to 0.5. Since 0.88 is greater than 0.5, the model predicts the student will pass class 1. Explain the k-means clustering algorithm with steps. Discuss how initial centroids influence results. Algorithm k-means clustering. Goal is to partition a data set into k distance non-overlapping subgroups clusters. The step is to initialization. Choose the number of clusters k, select k random data points as the initial centroids. Assignment step: for every data point in the dataset, calculate its distance to each centroid, assign the point to the closest centroid, and update step: recalculate the centroids. The new centroid of a cluster is the mean average position of all the points assigned to it. Repeat Repeat steps 2 and 3 until the centroid stops moving. Convergence: influence of initial centroids. Now we have k-mean is very sensitive to where you start. The algorithm finds a local optimum, not necessarily a global optimum. The problem getting stuck: if you pick two initial centroids that are very close to each other in the same natural cluster, the algorithm might split a single good cluster into two bad ones. Once the algorithm settles, it can't jump out of this bad arrangement. The consequences: different results. Running k-means twice on the exact same data with different random starts can give you completely different clusters. Slower convergence: bad starting point mean the centroids have to travel further, taking more iterations to finish. Now the solution: k-means plus plus. Instead of picking centroids purely at random, k-means plus plus picks the first one randomly, then picks the next ones to be as far as possible from the first. This spreads them out and lead to much better, more stable results. Completely demonstrate the clustering algorithm and computer KNN classification example using a Euclidean distance. So we have part 1, k-mean clustering demonstration. The goal is to group the data into clusters without labels. Dataset 1D for simplicity. We have dataset, choose k is equals to 2. We want two clusters. Step 1 is to initialization. Pick two random centroids. C1 is equals to 4, C2 is equals to 12. Step 2 is assignment. Iteration 1. Measure distance from every point to C1 4 and C2 12. Assign to the closest. Closer to 4 is cluster 1. Closer to 12 is cluster 2. Note we have 2, so 10 joins the cluster 2. Step 3, update centroid. Calculate the mean of the new clusters. New C1 is equals to 3, new C2 is equals to 18. Step 4 is repeat assignment iteration to measure distance to new C1 3 and new C2 18. We have to closer to 3, which is cluster 1, and closer to 18, which is cluster 2. Now final fifth step is the final update. Recalculates means until they stop changing. Final clusters are k is equals to 3. We have 2 3 4 small values, 10 11 12 medium, 20 25 30 large. With k is equals to 3, this would be perfect. With k is equals to 2, find the bed split. Now we have Canaan classification and example. Classify a new point x33 using k3. K is equals to 3. Training data: a11 class is equals to red, a12 class is equals to red, c44 class is equals to blue, d55 class is equals to blue. Calculate step 1. Calculate Euclidean distance by putting the values in the formula. We have distance xa is equals to 2.83, distance xb is equals to 2.24, xc is equals to 1.41, xd is equals to 2.83. Step 2, sort and pick. K is equals to 3. First C is equals to blue, second B is equals to red, third A is equals to red, fourth D is tied with A, but we only need 3. Step 3 is majority vote. Neighbors blue red red, winner is red 2 versus 1. Final prediction: point X belongs to class red. Now we have compare decision tree, random forest, and boosting, highlighting strength and weakness of each. Decision tree is single tree, random tree is ensemble parallel, and boosting tree is ensemble sequential. Goal of decision tree: to minimize impurity in one shot. Random tree reduce variance stability. Boosting is to reduce bias accuracy. Strength of decision tree: interpretable, easy to explain, fast, quick to train, no scaling, works on raw data. Random forest: robust, hard to overfit, accurate, handles high dimension as well, outliers handles them as well. Boosting: high accuracy, often wins competition, smart, learns complex patterns, precision, low error rate. Weakness of the decision tree: overfitting, high variance, unstable, small data changes, break it, weak, low accuracy on complex data. Random forest: black box, hard to interpret, slow prediction, must query 100 plus trees, heavy, requires more memory. And boosting: Noise sensitive can overfit outliers. Slow training trees must wait for previous one. Hard to tune many settings. Now show how basic logic gates can be built using single layer neutral networks. We have gate number of neutrons, activation function, back propagation needed. The concept is that a single neuron perception can simulate basic logic gates and or not by acting as a linear classifier. It learns a straight line decision boundary that separates two outputs from false outputs. The perceptron formula y is equals to activation. We use the step function as activation output 1 if result is greater than equal to else 0. And gate both must be 1. So logic would be 1 true. Or gate at least 1 is 1. So logic would be 1 true true. Not gate inverter. Logic would be 0 ka 1 and 1 ka 0. XOR gate exclusive or problem XOR gate outputs 1 only if inputs are different 0 1 or 1 0. Linear separability, you cannot draw a single straight line to separate these outputs. Solution, a single layer network cannot solve XOR. You need a multi-layer perception MLP with a hidden layer. Now we have putting the AND or NOT XOR in the numbers of neuron 1 1 1 1 3 min 2 layers. Activation function step threshold step sigmoid in the last one. Propagation needed, no. Manual weights, no. Manual weights, no. Manual weights XOR, yes, usually. Consider the following sample dataset. Calculate information gain for age, income, student and credit rating. Find which attribute gives the best first split highest gain. We have ID from 1 to 11, students, youth, middle, senior, age high, medium, low, income no, yes, credit rating fair, excellent, and by computer no, yes. Now calculate information gain for each attribute. We calculate the expected entropy for each attribute and subtract it from the global entropy to get the gain. Attribute age column 2. We have values youth, middle, senior. Youth are 5 instances. Target is 3 yes, 2 no. Entropy is 0.971. Middle 4 instances. Target is 2 yes, 2 no. Entropy is 1.0000. Seniors 5 instances. Target 3 yes, 2 no. Entropy is 0.71 and gain is equals to 0.005. Attribute income 3 column values high, medium, low. High 5 instances. Target 3 yes, 2 0. Entropy is 0.971, same distribution as youth. Medium 5 instances. Target yes, 4 yes, 1 no. Entropy is 0.722. Low 4 instances. Target 1 yes, 3 no. Entropy is 0.811. We have gain income is equals to 0.148. Now we have C attribute column 4, attribute student column 4 value yes or no. Yes 8 instances. Target is 6 yes, 2 no. Entropy is 0.811. No 6 instances. Target 2 yes, 4 no. Entropy is 0.918. Now gain of students is 0.128. Attribute credit rating column 5. Values are fair and excellent. Fair 8 instances. Target 6 yes, 2 no. Entropy is 0.811, same as student is equals to yes. Excellent 6 instances. Targeted 2 yes and 4 no. Entropy is equals to 0.918, same as student is equals to no. So gain of credit point is equals to 0.128. Conclusion, comparing the information gains. Gain of age is equals to 0.005, gain of income is equals to 0.148, gain of student 0.128, gain of credit 0.128. Attribute income provides the highest information gain 0.148 and should be chosen as the first best split for this decision tree. Now we have calculate Gini index for all the attributes of question 9a. Find the best first split and then build the complete decision tree. Now calculate the Gini index of the entire dataset T. First, we determine the purity of the target class, which is bias computer. Total instances 14, class yes, 8 instances, class no, 6 instances. We will put the formula of Gini D 1 minus summation of pi ka whole square. We have value 0.4898. Step 2 is to calculate Gini index for each attribute. We split data set by each attribute and calculate the weighted Gini index for the resulting subset. The attribute with the lowest weighted Gini index is the best split. Attribute age youth is equals to 0.48, middle is equals to 0.50, senior is equals to 0.48. The Gini age of D is equals to 0.4857. Now we have to attribute income. High 0.48 है, medium 0.32 है, low 0.375 है. So Gini income D is equals to 0.3929. We have attribute student no is equals to 0.444, yes is equals to 8, 0 is equals to 0.375. Now Gini student of D is equals to 0.4048. Attribute credit rating fair is equals to 0.375. Excellent is equals to 0.4444. Gini credit D is equals to 0.4048. Step 3, best first split comparing the weighted Gini indices. Age is equals to 0.4857, income 0.3929, lowest student 0.4048, credit rating 0.4048. Conclusion, the best attribute for the first split is income. Now we will make the decision tree of it. Draw the two decision tree, one from information gain, one from Gini index. Then compare the final rules from the both trees. The decision tree using information gain tree structure, and it is the decision tree using Gini index card. Comparison of final rules is information gain tree. Root node is income. Gini index tree, root node is income. Income is equals to high split, identical split on students in gain tree, and identical splits on students in Gini index. Income is equals to low split, splits on age, but all the branches lead to yes. Split on age leading to mixed decision, youth yes, others no. Income is equals to medium split, splits on credit rating, then students. Split on age, the credit rating, then students. Rule complexity resulted in a shallower tree with 8 rules. The split on income is equals to low led to a pure not immediately, resulted in a deeper, more complex tree with 10 rules. It explored income is equals to low and income is equals to medium more thoroughly. Now interpretation, the information gain tree is a simpler and easier to interpret, particularly the income is equals to low branch, which become a single rule. The Gini index tree is more granular. It founds nuances within the income is equals to low and income is equals to medium branches that the info gain method simplifies. Thank you. That is all for our data science and some paper.